So this is the first episode of the series, and we're going to be ranging from the most easiest and basic parts of number theory to the most hardest and challenging parts of number theory. And we're going to include all of it. So we're going to start with this problem. How many positive integers are between 50 and 101 inclusive? So before we solve this problem, I want to make sure that we define some pretty important terminology. So the first term that we want to define is positive. And although it might not seem important, positive is a pretty important term that we need to define. So positive is any number, integer, or anything that is more or greater than 0. So a number x is greater than 0. That's defining positive. So if a number x is greater than 0, then it is positive. So in this case, we're talking about positive integers. So first we have to define integers. There's 3 categories of integers. There's first positive integers. So they're integers greater than 0. And integers in general are just whole numbers. So they're -10 is an integer, 1 is an integer, 0 is an integer, 5 is an integer. You just can't have a fraction or a decimal. Decimal in the integer. So pi is in an integer because it's equal to 3.14 continued. And as you see here, as a decimal, square root of 5 can't be an integer because it is irrational and it has a decimal. And 1/4 can't be an integer because its translation is just 0.25, and that also has a decimal. So all numbers with decimals can't be integers, and integers fall in the category of numbers. So another way to say positive integers is just counting integers, and there's a relationship there because you count with your fingers, and when you count with your fingers, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all positive. So there's a relationship there, but just remember positive integers are integers greater than 0. So we have negative integers, and they're integers less than 0. 0 is just 0, and 0 is just 0. So those are the 3 subcategories of integers. And as you can see on the number line, here are the negative integers. Here's 0, and here is the positive integers. So mainly we just use positive integers and 0 as in math competitions. However, negative integers are also assessed. Okay, so now we know what positive integers are because we only need positive integers, the term positive integers, to solve this problem. And the problem is asking how many positive integers are between 50 and 101 inclusive. So if we just want to, if we don't know this problem and we just want to solve an easier problem first, we can solve how many positive integers are between 1 and 10. 10. So we can use the number line to find the integers from 1 to 10. And as you see here, how many from 1 to 10, how many gaps are there? So how many gaps or differences are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9 gaps. So if there's 9 gaps or differences, that means there's one less. That means it's just the subtraction of 10, the difference between 10 and 1. So 10 minus 1 is just 9, and that's the number of gaps. Gaps, which is just the difference between the numbers. Okay, so if you have 9 gaps, that's not the total amount of numbers. There's always one more number to count than the number of gaps. As you hear, 1 can coincide with 2, 2 can coincide with 3, 3 can coincide with 4, 4 can go with 5, and 9 can go with 10. However, we're missing 1. So we're always missing one number. So that means we just add the number of gaps and one more to include all the numbers. All numbers. So we just find the number of gaps, which is 10 minus 1, which is 9. And we find, we add 1 because we're missing one of the numbers that coincide with the other. So when we subtract, we're missing one number and we just add it back. And that works with any from 5 to 3. That works with any pairs of numbers. So 5 to 3, a little shorter, but there's 2 gaps. 1, 2. 5 minus 3, that's 2. We're counting the number of gaps. So there's 2 gaps. And if we just add 1, we'll make sure to add the missing number. And we get 3. And there are 3 numbers. So we know that this works. So we can subtract the last number from the first number, and then we can add 1 because we know that there is one less. There's one more than the gaps, number of gaps. Okay, the gaps will be useful later on when counting arithmetic sequences, but right now we don't need to do any more on that. So we counted the positive integers from 1 to 10 inclusive. That's just 10. Because 10 minus 1, 9, plus 1 again. So that's just 10. And so we're going to count something even harder. So count the numbers to 1 through 52. And that's just 52. So 52 minus 1 is just 51. And we're adding 1, which is 52. So there's 52 numbers from 1 to 52 inclusive. And now we can go to our original problem, 50 to 101. And what do you see here? So if we add 49 to both of the numbers, we don't change a single thing. That means 1 plus 49, which is 50, and 52 plus 49, which is 101. So we're counting the same list. We're just adding 49, which means that we're still counting the same list. So 101 minus 50, 51, 51 plus 1, which is 52. So we just solved the problem. All we have to do is just the same thing. 1 through 52 is just 52 integers from 1 through 52, inclusive, and 50 to 101 is just 52 integers from inclusive. So we're just counting the entire same list. We're just making the numbers larger. Okay, so the answer to this problem is 52. And that concludes the first number theory mini.